This is the Forest Talks Back, a tree-mounted climate monitoring tool built for Side 361. It's installed on a Norway maple in the middle of the rock garden, and it measures four environmental variables in that one tree: soil moisture, air temperature, relative humidity, and light, and then translates them into a single health status a passerby can read, hear, and physically record. The idea behind the name: the tree can't speak, so the system speaks for it, turning invisible environmental stress into something people can perceive. The housing for the wires is a two-part 3D printed assembly in PLA, split by an internal shelf into two bays. The lower bay holds the soil moisture probe, letting it pass through and reach the ground below the unit, and it houses the speaker with an open path so the tunes can carry outside the enclosure, while the upper bay holds the ESP32 development board, the 9-volt battery, and the wiring. The front plate carries the sensing and interface openings, a rectangular window for the 16-character two-line LCD display, a circular bore for the momentary push button, a pair of small holes that give the temperature and humidity sensor airflow to outside air, so it reads the tree's microclimate and not the inside of a sealed box, and a hole at the top that exposes the photocell to ambient light. Corner bosses also take self-taping screws so the plate is removable for service. The mounting is deliberately non-invasive. Simple hooks are adhered to the enclosure back with glue and tape, and a rope through those hooks ties the unit to the trunk. Nothing penetrates the bark, no screws, no fasteners into the tree, so the monitoring system never becomes the source of the stress it's measuring.
Around the RCH tree there with a really weird.
One 9-volt battery feeds into a DC to DC buck converter set to 5 volts before hookup. The 5-volt rail powers the ESP32 development board and the display. The ESP32's onboard regulator then makes the 3.3-volt rail for the sensors. Everything shares one ground. Two sensors are digital, two are analog. The temperature and humidity sensor and the display's backpack share one I2C bus, two wires, GPIO21 and GPIO22. The soil moisture probe outputs an analog voltage into GPIO34. The photocell sits in a voltage divider with a 10 kilo ohm resistor. More light means a higher voltage on GPIO35. Both analog pins are input-only ADC pins, chosen so the readings stay clean. The push button on GPIO33 uses the chip's internal pull-up and simply switches to ground. The speaker can't be driven straight from a pin. An ESP32 tops at around 40 milliamps, so GPIO27 switches the transistor instead with a base resistor to limit the drive and a 100 ohm resistor to keep speaker current near 45 milliamps. The display takes its command over the same I2C bus as the sensor, and a micro SD card module on the SPI bus stores the data log. The firmware is a single-state machine. Idle means a blank screen and silence. In the background, it samples all four sensors every 5 seconds to a CSV file on the micro SD card every 60 seconds. Scoring works per sensor. Each variable has a 4 threshold band. For example, soil moisture is good between 35 and 70%, okay in the shoulders, and bad below 20 or above 85. The soil percentage comes from a 2-point calibration. We measured the raw analog value in dry air and water and interpolate between them. The overall status is worst input wins. If any one of those sensors is bad band, the tree reports bad. Status maps to 1, 2, or 3, healthy, okay, bad. A button press triggers the reveal. A fresh reading, then the status and live sensor values print to the display while the matching tune plays through the speaker. The display clears the moment the tune ends. Screen time equals the tune length by construction. This is the healthy tune. This is the neutral tune. And this is the bad tune. Good plays a rising major arpeggio, 4 notes climbing to a high held C, the conventional music signal for success. Okay plays 2 flat repeated notes, no direction or resolution, just neutral. Bad plays a descending minor line ending on a long low note, longs over 3 tunes. The struggling tree literally takes up more of your time and attention. Poster on the tree closes the loop. Read the status, open the matching drawer, good maps to blue crayons, okay to green and bad to orange and red. Colors chosen to match the mural's stained glass palette rather than traffic light convention, and color the next blank section of the mural. Each colored section is one observation. Over months, the mural becomes a human-drawn record of the tree's health, the forest talking back one crayon stroke at a time. Here's the loop in controlled conditions in the workshop. We're dipping the soil sensor in water, and we see that the status is bad because the humidity is too high. We lightly place it out and see that the status changes to healthy. When we take it fully out of the water, we see that the status again updates to bad. To verify the logic, we hold the temperature and humidity sensor in healthy room air, then black out the light sensor completely. The display reports bad, expose it back to light, and the status switches to healthy. One input change and the scoring responded exactly as designed. One tree, four sensors, one button. The electronics capture the data, the mural and the people who stop in the rock garden turn it into a record with a memory longer than any one semester.